I'm a data scientist, which means I try to do cool and sometimes useful things with data. The question is, can't we just let an AI do this? So, since the AI boom really kicked off in November 2022, I heard a wide range of ideas of what AI could do for us in insurance. It's from the very ambitious, basically leaving all of the claims process to an AI and basically replace the claim handler, which the previous panel pointed out is not really possible now. And to the more modest, oh, can we let an AI decide what kind of document this is? And for the latter example, you don't need an AI. You need 2 or 3 lines of code that says if the document name ends with .jpeg, it's an image, and if it ends with .pdf, it's a PDF. So it's so these ideas span a wide range in ambition, but are still united with the term or concept of AI. So I think there is a bit of concept confusion surrounding AI. I think generally when people think about AI, they think about these super intelligent machines that somewhere in the near or distant future will take over the world and make us slaves or batteries or whatever. But yet there's still this notion that basically when a computer does anything, like deciding what kind of document it is, it's also AI. So I, as a data scientist, have no idea what people mean when they say AI. And so I found an image on the internet, which is sadly not present here. Okay, but so you will have to focus now, which is the perfect time just before lunch. So, okay, so the image depicts a large circle where it says artificial intelligence, and then there are some inner circles to that circle. And artificial intelligence, the concept has actually been around since the 50s. And as you may know, they didn't have very impressive computer power back then, so they didn't produce very impressive intelligence. The concept of machine learning is according to this image from the internet, is showing a machine or a model data and letting the model adapt to the data to perform a specific task. And as time has gone, we have gotten more computer power, so we can do bigger models and we can show them more data. Data times computer power, as Andreas expressed this. And guess what? As time goes even more, we get bigger computer and we get more data, and that's when the term deep learning enters. So in deep learning, you get bigger models that can do more advanced tasks. They can recognize images of dogs or cats and differ these two. They can perform natural language processing tasks and so forth. And guess what? The previous year, the computers got even bigger, and we now have generative AI that we all can use and explore with ChatGPT. And instead of just responding dog or cat, we actually can have some sort of conversation with this. And we can, with other models, we can describe what kind of image we want, and we get a new image. So I would say that the first example would qualify for the generative AI circle, or perhaps some future circle within Gen AI we haven't yet got. And the latter example, deciding what kind of document it is, it's far out somewhere where, I don't know. It's not AI at least. Okay, but let's get a bit more concrete and look how examples of this are deployed in the claims process. So this is my team's achievements when it comes to support the claim process. We actually start before a claim even happening. We have a warning system that warns customers before a claim even happens. When if a claim happens and the customer enters our webpage, we help them to the right claim form. Let's skip this triage Venice part. We sort the claim department's email, which is perhaps not the most exciting task. We help personal injury claim handlers to set ICD codes. ICD codes is a code describing an injury, what body part is this, and what kind of injury. And we also help to assess if the claim is covered or not. We help with fraud detection, and we also have a system identifying recourses or subrogations. So let's start from the beginning, before a claim even happens. So this system or project is called Pretoria, and it stands for Prevention and Trends Identification Algorithm, I think at least. It was actually I who came up with the name, so I should know. So the vision is this. Let's say we have some event that is triggering a lot of claims. We can think of this as a weather event, storms, flooding, or whatever. We can also think of it as a gang of thieves doing burglaries, stealing cars or stealing parts of cars, and they are doing this in the area or moving around in the country. So the vision is this: we identify these events, we reach out to our customers saying, take some precaution, and the claim rate will drop. This is the idea at least. And to identify these events, our idea is to look at our claims. So we know we have a lot of claims in Trygg-Hansa. We know when they happened and where they happened. And we also have some kind of description to each claim, describing more in detail what happened. So what we want to do here is we want to pick some region in Sweden, let's say Malmö, and we want to pick a period of time. And we want to say, during this time in Malmö, it happened an unusual amount of claims. So what we do is we develop a model that predicts how many claims there would be in Malmö this period of time. What we then do is compare with the real outcome. So if there is an unexpected amount of claims, we can reach out to our customers saying, hey, there has been a lot of burglars in your area recently. Please take precaution. And so we can also be more specific, and hold on to your hats now. We can also, besides a geographical region, add a contextual region based on the claim descriptions. So claim descriptions describing similar types of events will end up close to each other in this contextual region. And so let's say 2 claims describing thefts of car catalysts will be close to each other. And we can thus be more specific in our reaching out to our customers, pinpointing, let's say, car catalysts or other similar events, not just geographical closeness. Okay, so how many think this is AI? No one? Okay, 2 people, 3, 4. And this is actually a trick question, because I don't think it's qualified as AI, because even though this might be more advanced and well done than other AI models, this is pure statistics. It's a tempospatial Poisson process simulated with Monte Carlo. Yeah, a lot of fancy word, but it's still, yeah, it's not technically AI. Okay, So let's say that a claim actually happens, then a customer might enter our web page to file a claim. They will be met by this, or you will actually click report claim first. They will be asked to describe what has happened, and they might say, my cell phone got stolen at a coffee shop. And we then have developed a model that takes this text, classifies it, and puts the customer into the right claim form, or hopefully at least. In this case, house and content stolen objects claim form. And if the customer will enter a text describing a collision, we will send them to the collision claims form. This is actually from a data scientist perspective, this is kind of a typical problem. We have some text and we want to put it into different categories. And for this, we actually use deep learning, a model called BERT that was considered a large language model like 6 years ago. Now it's kind of a small large language model compared with the new kids on the block like ChatGPT and so forth. So yeah, but it still does the job, I would argue. Okay, here we have a missing slide as well. So our next project that classifies ICD codes, that is called Lucia. That is also some funny abbreviation, which large languages, yeah, I don't know. It's a quite similar problem, classifying text into different categories, in this case ICD codes. But for this we actually use a large language models, and it's a bit of a different approach. In the previous example, it showed this still large model, a lot of example of text, and it learns to pick out the patterns and so on. And here we just can show a small amount of example and give it instructions, and the model in some sense think for itself. This also goes for the coverage part, where we can send the terms and conditions in the prompt to the LLM, and the LLM can in some sense reason around if the claim is compensatable or not. And so this is kind of two similar problems solved in like more traditional data scientist way, and one with the new LLM prompting, which, yeah. So, and we have our fraud detection, which is what I work mostly with. And this is kind of the most simple model we will touch upon today. Because I think fraud detection is hard, but not perhaps as complex as other tasks. If you got your insurance yesterday and you file a claim today, you don't need billions of parameters to figure out that this is suspicious. So you can go with a quite small and easy model here. And the fraud engine here just gets data from our claim system enriched with Upptec data. And we get policy information, enrich it with some external sources, and we get a fraud evaluation. Yes. So in some kind of conclusion, I think one still should ask, hey, can't we let an AI do this, even though it's kind of a bit fussy what AI means. And I think the point here is that at least I want you, that is in the organization, to ask us data scientists, hey, can't we solve this problem in a data-driven way? And it's up to us data scientists if we want to use cutting-edge technology or just the most simple of models or even rules. However, I also think it will be increasingly important for people in the organization that perhaps not have as a technical background to be able to distinguish between easy tasks and tasks that requires cutting-edge technology. Because it will become increasingly important with AI and data-driven solution, as all of this kind of summits points out, and like the previous panel pointed out. So it will be important for everyone to be able to distinguish between them. Like I, as a data scientist, have to have some sense of law. I have some sense of what I can do and cannot do with respect to GDPR, for instance. And more importantly, I know when I should go and ask the legal department if, hey, I can do this. Can I do this? Is it allowed? So, and I think this, yeah, it's important for the organizations to pick up this kind of distinctions. So, well, with that, I just want to say thank you for listening.